In this video, I'll be discussing the concept of dimensional analysis. Our objective will be to convert between different units by applying conversion factors, otherwise known as dimensional analysis. This will directly draw on skills from the metric prefix video, so be sure to pause and re-watch that video before continuing. What do this Mars Climate Orbiter and this Air Canada jet have in common? They both suffered from poor unit conversion between English and metric units. In the Air Canada jet, this caused it to run out of fuel, whereas in the Mars Climate Orbiter, it caused it to navigate incorrectly. Both of these are really important examples of why unit conversion is so important and why we need to learn to master this skill in general chemistry. For the Air Canada jet, it was fueled in the US, and it was assumed that its density was in pounds per liter. Density is the ratio of an object's mass to its volume. It's an intensive property, meaning it doesn't depend on how much you have. In the case of the jet, it was assumed that there were 1.77 pounds of fuel per liter. Fuel in this case was measured in liters as it was put into the plane. But it turns out that this Air Canada jet was programmed in Canada, which uses the metric system. Therefore, the units were actually in kilograms per liter. Let's convert from pounds per liter to kilograms using the conversion factor 1 pound is equal to 454 grams. It's often useful to put these conversion factors into fractional form so that we can cancel units appropriately. In this case, we can write 1 pound is equivalent to 454 grams. Remember, this allows us to cancel units that are in the numerator of one term with units in the denominator from another term. And you may want to look back at the metric prefix video to remind yourself of why that is. But quickly to review, if each one of these terms in the numerator and the denominator represents units, the units that are in the numerator of one term will cancel with the denominator of another term. This will also happen in the case of the 4 dots, being left behind 3 dots in the numerator and 1 in the denominator for our final units as shown in this domino. In the case of this problem, we'll start with the given information. There are 1.77 pounds per liter. This was assumed to be the fuel density. We don't have a direct way to convert from pounds to kilograms, so we need to apply a 2-step conversion factor. Both steps are shown here. The first places pounds in the denominator and grams in the numerator, so that pounds cancels with pounds. And then we need to convert from grams to kilograms. We can do that using the metric prefix knowledge, which is that per every kilogram, there are 1,000 grams. Grams cancels with grams. To solve this problem, we'll multiply 1.77 times 454 and divide by 1,000. This gives us a value of 0.804 with units of kilograms in the numerator and liters in the denominator. What this means is that only about half of the fuel that was necessary was added to the plane. But don't worry, the plane made an emergency landing and no one got hurt. Still, this is a really important example of why unit conversion is a critical skill that we need to master. We can measure the density of a particular liquid in lab. The one method to do so would be to take an empty cylinder and measure the mass, add a known volume of liquid, and then measure the mass again. Because density is a ratio of the object's mass per volume, we can calculate it by taking the mass of the liquid, which is the mass of the cylinder plus the liquid, minus the mass of the cylinder, divided by the volume. This gives us a value of 0.788 grams per milliliter. If you were curious about determining the identity of this liquid, you could do so with a density table. Here's one example where densities are given in units of kilogram per meter cubed. But in the lab, we had to measure the units in terms of gram per milliliter. So we need to convert between gram per milliliter and kilogram per meter cubed. What a kilogram per meter cubed is in terms of a density unit is how much a meter cubed of a substance weighs in kilograms. Let's determine the liquid's identity. We're given the information that 1 centimeter cubed is equal to a milliliter, which will be really important as a conversion factor in this problem. The first step in a complex problem like this is to sort. What's the given information? We have density in gram per milliliter, and we need to convert to kilogram per meter cubed. You may also write in this area the conversion factor. 1 centimeter cubed is equal to 1 milliliter. Strategize. How are we going to convert? We have both mass units in the numerator and volume units in the denominator of our terms. We could break this into 2 steps in our head, where in the first step we convert mass from grams to kilograms, and in the second step we convert volume. You'll note that the second step is a little bit more complex because we don't have a direct way to convert between milliliters and meters cubed. We need to first convert to centimeters cubed and then meters cubed. Let's apply our strategy. I like to first write out the units because that helps me keep track of where they are and which units need to go in the numerator and denominator so that I don't get too lost later on. We're starting with grams per milliliter. Then we're first going to convert grams to kilograms. Grams goes in the denominator. Then milliliters to centimeters cubed. Remember, milliliters goes in the numerator because it's canceling the milliliters on the first term in the denominator. And then last but not least, centimeters cubed to meters cubed. Now I want to take a second to talk about this unit. We know from metric prefixes that there are 100 centimeters per 1 meter. This doesn't mean, however, that there are 100 centimeters cubed per 1 meter cubed. This is not true. Instead, we need to cube this entire term, cubing both sides of the equation. This can be easily conceptualized by writing out the conversion factor 3 times. What this does is tells us that a centimeter times a centimeter times a centimeter is a centimeter cubed, and a meter times a meter times a meter is a meter cubed. We also need to cube 101 in this calculation. Let's write it out in its full form starting from the beginning, and we'll use this unit set as our guide. We start with 0.788 grams per milliliter. We know that there are 1,000 grams in a kilogram, as you'll recall from metric prefixes. We were given in the problem that 1 milliliter is equal to 1 centimeter cubed, and that will be helpful for you to remember when converting densities and volumes in general. And then we'll apply our 3 conversion factors. Centimeters on the top so that it will cancel with the centimeters cubed on the bottom. When we do the unit analysis, grams cancels, milliliters cancels, centimeters cubed, remember, centimeters, 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 that's a centimeter cubed, so that cancels. Now, when we finally do our calculation, we'll get 788, and our units will be kilograms in the numerator, and meter times meter times meter, meter cubed in the denominator. We can check that the answer makes sense by the unit analysis like I just described, or in this case by confirming the order of magnitude with the table. There may be other ways that we can confirm this information through further experiments or other steps that we'll describe in future problem-solving sessions. Our goal today was to give an example of how to convert between different units using dimensional analysis. In other words, this dominoes type analogy. This will be most useful if you take it and practice multiple questions on your own so that you can really completely understand this objective and get really good practice with these types of conversion problems. We'll be approaching lots of different conversion problems throughout the semester, so now is a good time to practice. Thanks for watching, and I'll see you in the next video.